All right, guys, so in this first, there's three parts to tomorrow's open-ended test. There's the scatter plot that we're going to be doing. We're going to be plotting these points on the graph, and we're also going to draw the line that best fits by picking 2 points. And we're going to use those 2 points to write an equation, then change it to slope-intercept form. The second portion, and I'm not sure if it's going to be in this specific order, but I know that all 3 parts are on there. The second portion is where I give you, I give you the graph of a piecewise function, and you need to actually come up with the f of x function and those 3 pieces that represent this graph. Okay, it's easier than what it looks. And down here, the third portion is just to describe in complete sentences how the parent graph gets transformed to become this new graph up here. All right, so let's take one of these at a time. Let's start with the scatter plot. And let's start by plotting these points. Again, you got to look at this coordinate 1, 1 and go 1, and be careful. On the test, I believe they will be units of 1, but in this case it's not units of 1, it's units of 3 going up. So 1, 1 would actually be 1 this way and 1/3 of the way up right there. Not quite halfway, 1/3 of the way up. And then you have 3, 5, and we're going to go 1, 2, 3, and then 5. You have 3. 5 is almost to 6, so we're going to put it right there. And I'm going to plot the rest of these instantly. You could plot it yourself. I'm going to pause it and plot. So there are the plotted points. And now what we need to do is to use 2 of these points. It might be this one and this one. It might be this one and this one. You got to pick 2 of the points that give you the line that best fits. So it's a good idea to use your pencil or some type of straight edge to see which 2 points actually give that to you. I'm going to just draw a line. And I want to use this line to figure out which 2 points are the best. So if I put my line through those 2 points, that is not a good line that best fits, right? If I put it between these 2 points, and I'm talking about, let me show you here, this one and this one, that would be pretty good. But the best one, if you're able to, is to check the first one and the last one. Now this is not always going to work, but in this case it does. The first one and the last one pretty much gives you the line that best fits. Now these 2 points also work because it's going right through these 2 points. So you could use these 2 points, or you could even use these 2 points. But it's pretty clear that if you use different points, like if you were to use these guys right here, it'd give you a line that's messed up, right? So try to find the coordinates that give you the line that best represents all of your points. Now, you got to know which points you're using. And like I said, I'm going to be using this first point, which is this guy over here, and this last point, which is 815, okay? So once you know that you're going to use those, you could use those for the slope formula. The slope formula is m equals y2 minus y1 over x2 minus x1. And the best way to use the slope formula is to do your division and your subtractions first, and then actually plug in your values. So if we call this first point up here our first point, if we call this one our second point, then we really do have our y2, which would be 15, and y1, which would be 1. So if I plug in y2, which is 15, and y1, which is 1, I have my numerator. And if I plug in my x2, which is 8, and my x1, which is 1, I have 8 here and 1 there. Does that make sense to everybody? Again, this is a coordinate up here. This is a coordinate down here. We're using those 2 coordinates. This is your x1, y1, and this is your x2, y2. And that's how we got these values and plugged them in. Now, whoops, oh no, that's not good. Give me a second. So, the slope will be, if you do this correctly, 15 take away 1 is 14, 8 take away 1 is 7, so your slope is 2, yay? We have our m value. And now, we need to write the equation, and what do we really have here? What do we find? We found the slope, and of course we have points, okay? So let's use point-slope form. Hopefully you remember point slope form. It's y minus y1 equals m parenthesis x minus x1. That is point slope form. So I'm going to use the first point that we used on our line that best fits, which was 1, 1. So I'm going to rewrite the point slope formula, or the point slope form of the equation y minus y1, but instead of y1, what am I going to put? Everybody's awake, huh? 1. Okay, and then we're going to put equals m. We just found out that m was 2. Now we're going to put the parenthesis there, and then x minus x1, which is going to be minus what? 1. Thank you. Okay, so there's our point slope form equation. Now all we need to do is change it to slope-intercept form by getting rid of the parentheses by distributing. So I will have, let me rewrite this over here on the side, y minus 1 equals 2x minus 2. And then we add 1 to both sides, and we'll have y equals 2x minus 1. And that's your line that best fits equation. Okay, so on the open-ended part, just like on the quiz that we took before, you're going to get points for plotting it correctly. You're going to get points for drawing the line that best fits correctly. And then you're going to get points by showing your algebra. You have to show your work here by picking the 2 points that you use for your line that best fits and using those 2 points to actually find the slope using the slope formula. And once you have the slope, then you could pick your point from the original table and use your point and your slope to write it in point slope form and then transform it or change it to slope-intercept form. So all that is going to be one question on tomorrow's open-ended part. Let's move on to the second part. Now this one's a little bit more interesting because most of the time I give you a piecewise function and I ask you to graph it, right? This time I'm going to give you a graph and you need to be able to write the piecewise function. So what we need to do is understand what this line is, but imagine if it were the whole thing. What would this line be, guys? This one right here. Would it be x equals something, or what? X equals something like this. So x equals negative 1, x equals positive 2, x equals 10. What is this really? Not x equals, but what? Y equals. So y equals what? What is this equation right here? Okay, so if, let's pretend that this thing went way out this way, then that equation will be y equals negative 3. Yay? Okay, but it's not, right? It's only this portion of it over here. But the fact is, it is this line, but it's only this piece. So the piece comes from the domain, the restriction that we give on the piecewise function. So everybody on our paper, we should start out by having like f of x equals, and you got this like, what is that? That's disgusting. Anyways, let's put this first piece up there as an equation. Now you're not going to write y equals negative 3 right here because remember the f of x represents the y part. So it's already saying y equals, so what do I write up here on the first part? Negative 3. I hope you guys see that. Now, what portion am I looking at? Am I looking at this side of negative 3, y equals negative 3, or this side of y equals negative 3? I'm looking at the left side. So what is my restriction going to be? That the piece of this graph that I'm looking at has to be less than what? Less than, 2's over here, less than negative 2, right? So what we need to do is write if x is less than negative 2. Now notice I didn't write less than or equal to because it's an open dot. Does this make sense? Okay, now why did I start with this one? Why didn't I start with this one or with the middle one? Because when we look at graphs, we look at them from left to right. Now this was the first portion I saw, so that's what I write first. Okay? Let's move on to this middle portion. Well, let's forget about the actual piece of it. Let's look at the whole line. What is this whole line actually? If I wanted to write that whole line, what would it be? Well, could you write an equation off the top of your head? Maybe in y equals mx plus b form that crosses through here and that rises and runs like that? What would that equation be? Anybody? if it were going forever, to the left and to the right, if it were, but it's not really. But if it were going forever, it would be y equals what? Y equals, I'm not talking about domain and range yet. Y equals, I'm talking about specifically, how much do you rise and run from here to here? 1 over 1. So that's just 1. M is 1, so y equals x. Whoa. Y equals x. And where does it cross the y-axis? 0. So you don't need to put plus 0. You could if you want. But the bottom line is, this is your line. But this line goes forever, and you don't want the forever part. So let's write this line right here in the middle portion, because that's a middle portion going from left to right. So what am I going to write right here? It says y equals x. Am I going to write y equals x right here? The answer is no. Why? Because f of x already represents y. So it already says y equals, and what do I need to write right here? X. Y equals x. Y equals x. Okay. Now, what restrictions do we want to give this line? Does it go forever to the left? Does it go forever? Does it exist over here? No, it stops right there, right? Does it go forever to the right? No, it stops right there, right? So we need to give it a restriction, guys. It's actually from this value on x all the way to this value on x. From here to here. Does that make sense? So let's think about what value this is. What is this value? -2. So it is from, so I'm going to put if. We're going to put -2. And we're going to put x in the middle. And what are we going to put on the right side? This is what? 4. So we're going to put 4 on the right side. And what inequality symbols are we going to put in there? The less than or equal to. Less than or equal to. Because we put it in order, smaller number on this side, bigger number on that side, it has to be opening up to the right always. So this is our middle piece from here to here. That's our middle piece right there. Represented x if -2 is less than or equal to x, which is less than or equal to 4. In other words, from -2 to +4. From -2 to +4. Does that make sense? Finally, the third portion. What would this third line be up here? Imagine if it were to go this way forever, even though it doesn't. What would that equation actually be? Y equals what? I'm not talking about range or domain. I'm talking about the actual equation that'll produce a horizontal line left and right at the value of what? 5. So the equation is actually y equals 5. If you were to graph y equals 5, it would give you the whole thing running left to right in both directions, right? So if that's your equation, y equals 5, now that's the third piece. You want to write y equals 5 right here, but you're not going to write y equals 5 because this is already saying y equals, what am I going to put right here? 5, that's it. All right. Now let's think about the domain, the piece that we actually see from here that way. How do you show that you only want to see from here that way? You're going to put if, if what? If x is what? Yes, greater than what? There you go. Ladies and gentlemen, we're done. That is your detailed, perfect, piecewise function with the conditions also. You're showing the pieces that are shown right there.